Hello everyone, thanks for tuning in. This is Shaminder, and in today's video, I'm going to give a walkthrough of Azure Synapse Link with Dataverse. And the focus is on how to query data once the data is available in our data lake storage and exported out of Dataverse. There are different options and configurations available when you configure the Synapse Link for the first time. I'm not going to go over the setup of these, but I want to call out two key things which are essential as the way your data is exported would depend on it. The first one is whether you choose Synapse Analytic Workspace and Delta Lake format. If you do so, then your data is exported out in Parquet format, and you have Azure Synapse Analytic Workspace additional resources where there's a Spark cluster, and that Spark cluster is doing the job of converting your Dataverse data from CSV into Parquet and then pushing that data into your ADLS. It's more expensive because you have additional Azure resources. The other one is just exporting it to Azure Data Lake Storage. Now, this one doesn't require the creation of Azure Synapse Analytics Workspace, and your exported data is in the CSV format. Now that's the different infrastructure choice points available to you. Along with that, you have the option to select incremental updates and append only or in place modes when you configure your entity. So for this demo, I've configured incremental update and I've selected append only option. So that's why you see the timestamp specific formats over here. So the data is available in my data lake storage in CSV format. And this scenario may be applicable to you as well if you don't have your entire infrastructure on Azure and you want to keep your Azure infrastructure footprint minimal and your primarily goal is to get the data out of Dataverse, and then you can move that data to your analytics workloads wherever they exist. They could be on AWS, they could be on GCP, or on different reporting platform altogether. Now, once the data is available in CSV format. And the good thing with the Synapse Analytics workspace is it gives you the capability to create a serverless pool which utilizes Polybase and makes an external connection to these CSV files, and you can query those files directly within your serverless pool. Now, with our demo, we are going to do a similar thing, but without using Azure Synapse Analytics Workspace because our infrastructure footprint, our goal is to keep that minimal. So we'll not go via the route of utilizing Azure Synapse Analytics Workspace. So we'll be utilizing a couple of community tools to make that happen, and I'll call those out as I, go over those tools. But before I start the process and start querying the data, I do want to go over the structure of the files that I have in my data lake storage. So over here, you see two timestamp specific folders. The first folder contains the data of account and contact, and it contains its model.json. The second contains just the contact entity, and it also contains its model.json. Now, the model.json plays a key role in the Synapse link because the files that you have exported out, primarily if they are in CSV format, they do not have headers in it, and you do not get any schema information in them. It resides into this model.json. Okay, so if I go into my model.json over here, you would see, so this model.json follows common data model, and then it has this entities properties where all the entities that you have configured in Dataverse for sync would appear here, and the metadata of those entities, their attributes would also be present along with their data types and the constraints like, okay, what is the max length on it? So this way, your data type and your schema information is preserved in model.json and your data resides in CSV file. If you choose Azure Synapse Analytics Workspace and Parquet format, all of this is directly embedded into your Parquet file. Um, However, if you have CSV, then you'll have to rely on the model.json. And this is where in today's demo we'll leverage this model.json and do our queries. Now, if you're interested into Parquet format and how that makes our life easier, let me know in comments. I'll make a different video for it. And there also will explain different ways to do it by keeping the cost minimal. Okay. At this point, we know, okay, we have a data lake storage, our data is there in the CSV format, and now we want to query the data. So we'll utilize this we'll utilize this community tool called dbeaver. And within dbeaver, we'll utilize DuckDB plugin. If you don't know about DuckDB, it's an in-memory database that allows connections to different cloud providers, different file systems, and allows and has very rich capabilities of creating in-memory tables. We could do joins, views, everything. And the good thing is it's in memory. And if you want to persist the tables that you have created, those in-memory tables into a file, you could store it as a database file and then later load that file and it will contain all the information that you previously pushed into those in-memory tables. Okay, so I'll create a new connection in dbeaver, specify DuckDB. And this is where, depending on whether you just want to run it in memory or you want to preserve your in-memory tables that you have created into a database, you could initialize a database file here by providing the path of that file. But for me, in this demo, I'm just going to run it in memory mode. Okay, so now we have our session created. The first thing we'll have to do is within this session, we will load our Azure extension because our data resides in Azure. And as of now, DuckDB doesn't know, okay, how to connect to Azure. So for that, it needs to install this Azure extension. We do so by writing these two lines, install Azure and load Azure. Okay. The next thing is I have the script with me. I'll copy it over here and we'll go over what the script is doing and how we can query our data. Okay, so now that we have installed the extension, the next thing is to set up the connection from our DuckDB session to our Azure Data Lake storage, and we do so by declaring this secret. And here the type is Azure provider. Now the good thing is that DB has implemented all the supported connection mechanisms that Microsoft provides. You could connect using managed identity, you could connect using your CLI, you can connect using workload identity, you can connect using default Azure credential, you can connect using certificate. So depending on your preference, you can create this secret. So for me, I've just selected CLI as my first mode of connection. And if the CLI doesn't have any active connection, then piggyback on the default Azure credentials. So, but you could select any of the connection mechanism depending on your preference. Okay. Okay. And over here, the entity that I want to query is contact. This is my storage account name, and this is my container name where the files reside. So what I'm going to do now is, since I've specified CLI, so I'll create a session in CLI separately. Okay. Now using CLI, I've logged in into my pay-as-you-go subscription. So at this point, DuckDB should recognize that I have an active CLI session and it can use that session. So let's validate that. Yeah. So we got a success message back. The next thing I'm doing is, as we spoke about the model.json, so I want to get all the model.json files that are available in the subdirectories. You may want to limit this. I'm pulling the data out of all the subdirectories, but depending on your requirements, in case if you want to only get the data of this year, last year, or only specific months, you can adjust this wildcard filter and limit your data files so that you don't target all the CSV files. Okay, so I'll just pull this. And then the next thing, this is where I'm creating an in-memory table. So once I have formulated that path, I'm pulling those folder names into this in-memory table. Yeah, so these are the two folder name timestamp specific folder names that we saw in the data lake storage. And the next thing I'm doing here is I'm just creating a list out of it. And then I'm pulling that entities property out of that model.json because that's where our schema is stored and our data type information is stored. And we need it uh, to, to form a table which holds those data types, and then we load that data from the CSV into that table. Okay, so I have this table created. I'll show you what this table contains. Okay, so over here, this J property basically contains the entities JSON that was there in the model.json. It contains all the details about the partitions, the attributes, and then we have this file container that, okay, it's specific to this file container. Okay, now let's go ahead and look at the next section. So this is where what I'm doing is, okay, now I have that JSON, which contains all the attribute information, all the partition information. I'm parsing that information out and pushing it into its own variable into this table. Yeah, right. So over here you see, okay, this is the entity CDM schema. And I'll upload this script into my GitHub so that if you want to run it, you just change the variables at the top and it just starts working for you. Right. So this is what I'm doing now. Okay. In the file container, I have this file container. It has this account. So both the folders have the model.json, and the model.json has these two tables. And however, this folder doesn't contain any partition specific to account. It only contains contact file. This folder contains both account contact, and these are the location of those files. So the next thing I'm going to do is I'm going to translate this JSON that holds the schema information and map the CDM data type to my DuckDB data type so that I can then utilize those data types. Okay. So as I'm querying contact entity, now I have extracted that information successfully out of model.json and preserved into this table and mapped it into the DuckDB equivalent data type along with the max length constraint. And the next thing is basically I'm holding the partitions now and keeping track of where my files are for that entity, right? So for contact entity, I have two CSV files into two different folders, timestamp specific folders. So I know, okay, these are my partitions. Now, the only thing that's really pending is just go ahead and grab that information and utilize the schema that we have formulated and dump that into this table. Okay, sweet. Yeah. So now this information is coming from my those partition files, and over here you could see it has now successfully mapped the column names to the CSV, and now I can do queries on this data. So let's say, okay, this guy Carla Yates is coming twice. So this is the first time that it was inserted into Synapse Link and later an update happened and then it got pushed again. So this is where we can do audit also. So if I have to pull that guy out, okay, so now I have these two rows and now I can see, okay, what changed into this, what changed in this record, and then what file basically propagated that change to our Synapse link. So this is where we have full history. We have all the columns. Yeah, so you see, I changed the phone number from this value to this value, and we get to see that. So I have full history of what has happened with my data, even though I don't have audit enabled. And then I can then, you know, correlate it to the timestamp when that happened and find that exact file out of my data lake where that change was introduced. So this allows me to query the data without having any additional Azure infrastructure and just, running the queries against those CSV files directly. Now at the top, I can point it to any entity example. I'm changing contact to account and running it end to end. Oops, I just have to go down, change this to star because this one doesn't have. Right. So that way, it'll go and run it for any entity that's available. Like the count doesn't have those columns. That's why it failed. Oops, I have to also remove this weird clause because this guy doesn't exist. Let's cancel. Okay, there we go. Right. So some of these things, if you're doing the troubleshooting and data visualization on an everyday basis, so you could save this into a local file and have the information like schema already pushed into your in-memory tables. That way you don't have to load that information again and again from model.json. So it makes your script run a little bit faster because then you already have the schema and everything available with you, and all you are doing is just loading the data out of those CSV and doing queries on top of it. Okay, yeah, that's all what I wanted to showcase in this